On example 2, we're going to start graphing piecewise defined functions. And then after we graph, we need to find f of -3 and f of 2, and then state the domain of my function here. Okay, so for graphing for our part A, what we need to do is first make tables for our two equations. Now our two equations this time are just horizontal lines. So my first one is that y equals, because f of x also is y, so y equals 2 is going to be my first table here. And then my second one is y equals -3. Okay, so we want to start every time by making an equation here. Now, multiple things need to happen kind of at the same time here, and it doesn't really matter what you do first. Notice that both of these say that when x is less than or equal to -2, and here when x is greater than -2. So this right here means at -2 is where my two graphs are going to kind of split. So I'm going to have one graph over here to the left of -2, and then a separate graph over here to the right of -2. So because this -2, this breaking point is so important, this needs to be the first number in both of these tables here. And where that breaking point is very, very crucial. Now, both of these are not going to get open circles, and both of these are not going to get closed circles. You should have one of each. And if we had more than one equation, which again, I don't think we do, you're only going to have one open and one closed. But if you had 3 equations, you might have 2 open, but you would only have 1 closed. Okay, so for us, 1 open, 1 closed. Okay, so because this is less than or equal to, with this y equals 2, that equals means that this one here needs to be a nice, solid, closed circle. Because this -2 is included in this graph right here. But because this one is simply greater than 2, this one's going to be a nice, open circle. Everything else are going to be just regular points. But this one needs to be a very bold, closed circle. This one needs to be an open circle. Okay, if we look at that example that we did in that intro, you can see closed circles and open circles in here. Okay, so now I need to make a table of different values here. So if this one here is when x is less than or equal to -2, what's the next logical number here that is less than 2? And that would be -3, right? We're right here at -2. The next one is -3. Now, you only need 2 points at minimum. But to make a more accurate graph, put in a couple more values. So -4 and -5 would also be great numbers to put in. Now with this one, it does not really matter what the x is because I have no x in this equation. It simply says that y equals 2. So this one means we have 2 all the way down. So let's go ahead and plot this side here. So I'm going to have a nice closed circle at -2, 2. And then we have regular points from here on out. So -3, 2, -4, 2, and -5, 2. And if I could find my ruler, we're going to go from that orange point, from our bold point, through the rest of them. So we have an arrow right there. Okay, let's now do this table and figure out what goes on this side of our graph. So this one says when x is greater than -2. So what's the next logical number that's greater than 2? We got -1. Now, at minimum, you need at least 2 points, but go ahead and put a couple more values just to get more accurate. We're going to go 0 and then 1. Okay, now for the record, I always pick that next one over, but you don't have to pick -1. You can pick anything that's in this domain. So you could pick 2, you could pick 5, it does not matter, just something that meets this criteria of x is greater than 2. Now this equation doesn't have an x in it again, it's just y equals -3. So I have -3 all the way down here. So now we'll plot these points. At -2, -3, I have a nice open circle. And then regular points from here on out. So -1, -3, 0, -3, and 1, -3. And so we will go from our open circle here through the rest of those points. So here is my graph. So part B wants us to find f of -3 and f of 2. Now, if you fill this table out, most of your values are going to come straight from that table there. Remember, these are my x's. So if I have x is -3, well, here's where my x is -3. What does that equal? That equals 2. So right here, we get that point of 2. Okay, now we need f of 2, and we didn't quite go far enough. So you go ahead and do another point right here and put a 2, or you can just look at your graph. It doesn't matter how you want to do this. When your x right here is at 2, we're going to go down and meet that graph. What is that y value at that point? That y value is right there at -3. So either use your graph or use your table of values. And then C, we need to state the domain of the function. So domain, we go from left to right. So as I go from left to right, the first thing I hit is an arrow. That arrow represents -infinity. And then it's going to keep going. And then what happens here at -2? Well, I actually don't have a break in values because when it is less than -2, we're talking about all of these numbers here, but it equals -2 on this part of the graph. And then once you go more than -2, now we have all of these values here, and it's going to keep going on to infinity. So our domain is all real numbers or -infinity to infinity, which honestly you can look at right here. It says the exact same thing. When my x is less than or equal to -2, and when my x is greater than -2, we're not excluding any number whatsoever. So you can either look at your graph or look at the domain right here in your function.